Hi there, this is another example of finding the area between two curves. We've got sketch the graph of the region bounded by the curves of these two functions, f of x equals 2e to the power of negative x on 2 and g of x equals x squared minus 4x. And then we need to find the area. So sketch and find the area. And I just wanted to remind you of the three major steps that we use to find the area between two curves. Number one is to visualize. So you need to get that sketch so that you know which is the top function, which is the bottom function. Then we need to work out the points of intersection because that gives us our lower bound and upper bound for our integral. And then the third step is to do the integrate step. And I've got here via a new expression. And by that, you'll see in your textbook, for example, it says write an expression that symbolizes the area or something like that. And that simply means, quite simply, the new expression will be y1 minus y2, where just a reminder that that has to be the top function and that has to be the bottom function, like so. So they're the three steps. So the bad news is it's kind of complicated and difficult. You might have a bit of an idea in your head what a graph of e to the power of something looks like. So you can get a sense of what this might look like. It's a negative, so it's going to be decreasing over time. So it's going to be, sweeping up this, and x squared minus 4x is a quadratic, so it's going to be like this. That's the bad news. The good news is that we've got to use our GDC, our graphics display calculator, and this is what this example is all about. So let me switch Aruni over to the graphics display calculator, and I'm going to create a new document as a graph. And I'm going to put my two functions in because that's the easiest way, isn't it, to visualize, is to actually have the graph. So one is 2e to the power of negative x on 2. So 2e to the power of negative x on 2. Negative x over 2, like so. So I'll graph that. Oops, better put the right e in, huh? So I should stop and do this video again, but I won't. Instead, I'll go over it manually instead so we can get it right. So I'll just take that e out and replace it with the symbol over here for e, like so. Turn it into a bit of a bold e. Press return, and there's the graph of 2e to the negative x on 2. Okay, so that's that one done. And g of x equals x squared minus 4x. So I'm going to put that in again. So Control G to get my graph up. And now it says g of x, but f2 of x is going to stand in for my g. So it's x squared minus 4x. So x squared minus 4x, and graph that. And that's okay. So I'm looking at the area between here and here, knowing that the integral will be the integral of this minus the integral of this, effectively will give us this area here. Okay, so that's step one done, visualization. So whoop and whoop, like so. Without putting any of the critical points in, if I go back to my graph paper here and just very quickly draw my sketch in, I'm going to have this kind of thing happening like this. So that's f of x. And then I can see that my point of intersection is to the left here a little bit, and then it's over here a little bit, like so. So that's going to be the value 2, isn't it? So like that. That's pretty bad, isn't it? But it gives us a sense. So there's 1 and 1 there, kind of thing. So there's my visualization, and my area therefore is this bit inside here with g of x being labeled as this one. So I can see that for sure it's going to be f of x minus g of x, top minus bottom. So there's my visualization. It's really important because it could be g of x minus f of x, but it's not. Okay, back to my calculator. I need point 2 as my points of intersection. I need to work out the point of intersection between here and here. So I'll go to menu and I'll go to analyze graph and I'll go to intersection and I'll click somewhere to the left of the point of intersection and somewhere to the right of the point of intersection, and it's given me negative 0.584. So I'm only interested in the upper and lower bound really, so I'll just put negative 0.584 as my lower bound, and then I'll do the same thing for my upper bound. So I'm looking for that point of intersection there. So same deal, menu, analyze graph, intersection, lower bound, upper bound, and there it is there, 4.06. So it's only down to 3 significant figures, and ideally if it could do it to more, that would be good. That would probably make it a little bit better. I don't know if I can, no, I don't think I can get it more more accurate than that as it stands. Maybe there is a way of doing it, but we'll just deal with those, do with that knowing that the area is going to be not as accurate as I'd like it to be. So let me switch over to my whiteboard, and you can see I've written it down there. The boundaries are A and B. And so because we now know the upper bound is f of x and the lower bound, so the upper curve is f of x and the lower curve is g of x, then I know that what I'm doing is I'm working at the integral between negative 0.584 and 4.06 of 2 e to the negative x on 2 minus x squared minus 4x, all with respect to x. And that's equal to the integral negative 0.584 and 4.06 of 2e to the negative x on 2 minus x squared plus 4x. So that's the expression I need to integrate. Okay, so back we go. I'm just going to add a new page in, so Control Doc to add a new page, add a new calculator in, and I'm going to use my function library here to go to my definite integral. I'm going to start chucking in the values. So we've got negative 0.584, and then I've got 4.06. This is all to 3 significant figures, and I hope it's accurate enough. In here, I'll put my function, so it's 2 multiplied by e to the power of negative x on 2. I probably should put the whole thing in brackets too. And then minus x squared plus 4x, close brackets, and we need to tell them what it's, tell the calculator what it's with respect to. It's with respect to the variable x. Press return, and I get 14.742. I'm going to write that down on the whiteboard and go back in a second. 742, like so. And I just wanted to point out that one of the strengths of keeping your documents together as opposed to creating a brand new document is that from 1.1, f of x and g of x have already been defined. F of x is f1 of x and g of x is f2 of x. So what I could have done a little bit more simply really is I could have gone integral negative 0.584 and then gone to 4.06 And in here, I could have gone f1 of x minus f2 of x with respect to x, and there you go, same value, because it knows what f1 and f2 are. So do keep that in mind, that things calculated in one page of the document can then be translated to the second page of the document, and just saves you a little bit of mucking about if you know what you're on about. So 14.742 is our final answer there, and you can see I've written it down as my area as 14.742, and job is done. This was in fact an example taken from our textbook. And where is it? Have I gone too far? Yes, I have. I just wanted to show you. Oops, sorry. That was exciting, wasn't it? It was this one here, part B, 2 to the power of 2 times e to the power of negative x on 2 and x squared minus 4x. And they've got an answer of 14.7. Of course, they've gone to 3 significant figures, which is exactly the same answer as we had. You'll notice in the textbook it says keep it to more significant figures if you can. So that would be reasonable to do if you can, and if you can't, you're going to get an answer which is pretty reasonable anyway. Okay, so I think that will do for this GDC example of how to solve a problem.